Oh, also, this is a different oil. I forgot to tell you this. This is a different oil for the weight bearings. This is Vactor 2. And it just says V2 on here. And we have two different buckets of oil over there. And they say on the front, one of them says DTE 24, one of them says Vactor 2. The Vactor 2 is a little bit lighter body, and so it's going to flow a little bit better on these weight bearings.
So how often does that have to be, how often does that bottom area have to be refilled with a V2?
When it's about a third full, I'd probably refill it, just to make sure that you have enough. I mean, we ran it out last year.
How often does that, is that about during heavy build too? About once a year,
About
okay.
once a year.
Okay, so it's not be that much.
Yeah, during heavy use, yeah, you probably are going to use a lot of oil. But yeah, about once a year, you probably need to refill that with the way that we use it. Okay, we've got two different types of cutters that we use, or mill. These are end mills. We've got a 2-flute and a 4-flute. It makes a difference what type of material you're using, what type of a cutter that you use.
Could you show those up again kind of slowly, which one, and then point the edges to me?
All right, this is a 2-flute, because it had 2 cutting edges. And then we got a 4-flute, which has 4 cutting edges. The 2-flute is primarily used for aluminum or soft materials, Delrin, wax, wood. You could probably use it on harder materials like steel, but a 4-flute is going to do better because it has more cutting edges. You wouldn't want to use a 4-flute on aluminum, even if it was a hard aluminum like 7075. I would probably still use a 2-flute simply because what's going to happen is you're going to build up friction, and the soft material is going to clog this up, which can affect your surface finish. It can also actually melt. We've had this happen, had it melt and encrust the bit, and then that can damage your part. It can damage the cutter. So 2-flute for aluminum, 4-flute for harder things, steel and anything harder than steel. And then this is the collet. The collet holds the end mill, and they're sized according to the size of the mill. And what they're sized to is this shaft area right here, because you want this bit to fit down into this, and you want it to seat just like that. So you can see it fits real nicely in there. There's no slop in there. It fits. It's a nice, precise fit. And on these, especially the larger bits, you want it to go in as far as it will go. Now, on some of the smaller bits, you may have to adjust it just a little bit. And I'll show you a smaller bit here before long, and you will have to kind of align it. But you want just a little bit of the silver sticking out when you insert the bit into the collet. You don't want it all the way up in there. It's just about halfway out, but this one is a little more than that. But as far down as it will go, and then that's the way it should be with the 2-flute and with the 4-flute.
Great. When you demonstrate stuff in the middle, could you just kind of hold it in one place for a little bit as you go through, just so I can? Yep. Thank you.
So there's a 2-flute. Okay, when you put parts in the machine, on the collet, there's a keyway, and the keyway is going to align the keyway inside of the spindle. And so when I put that in there, usually the way that I do it is I'm going to put my bit in as far as I want it to go, and then I'll just put that whole assembly in there, and then you just turn it around until that keyway lines up. If it's not aligned, it won't go in, but you just turn it around until it lines up. And then you can, this is the drawbar. The drawbar is what holds it in. It's threaded on the end. The collet is also threaded on the end. And so those threads go together, hold it in. You can just thread it like this, but you've got to hold it a long time. And really, probably the most efficient way to do this is to push this all the way up as far as it'll go and hold it tight. And that makes this drawbar a lot easier to hand tighten. And I'll just hand tighten that. And then I'm going to take my 9/16 wrench. And this is a combination, but I like the box end better. It gives you a more positive turn on the drawbar. but this is going to fit right over the top of the drawbar. And then that's going to turn. Now, you can't tighten it like this. You're only going to get a certain amount of tightness and then see the bit is turning. So what I have to do is I have to use my brake arm, which is right here. So I'm going to hold down on the brake arm, and I'm just going to tighten this down. And this just has to be snug. You don't have to really crank on this. In fact, you're going to wear your drawbar out by tightening it too much. So you don't want to over tighten the drawbar because first of all, it's going to be hard to get loose. Second of all, you wear your drawbar out. So you don't want to wear the drawbar out, so just nice and snug. That's going to be plenty tight enough to hold your bit in securely. Because this has got a, it's got a tapered shaft, and so as it draws it up in there, it closes. The collet has a split in it, and so when it closes that split, then it holds the bit tight. Then make sure to remove the wrench. You can see here when we had a different drawbar before we broke it. This was the wrench that we used. You can see that's just about the same length. That little divot in the motor up there. So make that. What happened was somebody forgot to remove that, turned the spindle on. It turned around, whacked that thing, and broke the drawbar. And so make sure that you remove the wrench before you start powering. That's just a check on your setup that you have to do before you turn the power on. So bit is in tight. I've got it tightened down, I've got it adjusted, so I think we're about ready to move on then to...
Do you want to display how to remove the bit?
I do. So when you remove the bit, it's just going to be the reverse order. I'll hold down on the lever arm or the brake arm. Now, the drawbar, again, it's a tapered shaft, or it's a tapered fit. So even though the drawbar is loose, I can't pull that out of here. So what I have to do is I have to take my little handle here with it's got a knocker on the end of it, for lack of a better term. And then I'm just going to hold on to the bit. I'm just going to tap and loosen that up, and then make my bit drop out. And I want to make sure to hold on to that, because if I just tap it and let it fall out, you're going to damage these things. This is probably about a $100 bit. So we want to protect the edges of these as much as we can. And if it would happen to fall off and fall on the floor, you can damage the cutting edge of this. And so we want to protect those as much as we can. So hold on to the bit when you tap that out. Then I'll just push up on this again to loosen it, and then I'll just do this by hand. And then the collet just drops out.